Welcome to Kirchhoff's Rules Lab, and today we're going to explore more measurements of current and voltages using the Kirchhoff's rules. There are two Kirchhoff's rules. One is the Kirchhoff's voltage rule, and the other one is the Kirchhoff's current rule. The current rule states that all the currents going, the sum of all the currents going into a junction should equal to zero, and the Kirchhoff's voltage rule basically says that the sum of the voltages around a loop in a circuit is going to equal to zero. So previously we learned about Ohm's law, which basically stated that the voltage across a resistor is going to be equal to current going through it multiplied by its resistance. And also we learned about how to combine resistors in parallel and series and come up with a equivalent circuit. Today we're going to look at a special type of circuit that uses two power sources, so we cannot use the series and parallel rules to simplify the circuit. So what we need to do is we use the Kirchhoff's rules instead in order to basically measure or calculate the current and the voltages of resistors. So we measure the voltage again across the resistor, and current has to go through the resistor. So right now I have a circuit, the diagram number one. The circuit that you're working today is built here. So I don't have any power sources connected to either side of the circuit. So the resistors are loosely connected. Only one side of the resistors are connected to each other. So you could basically go right ahead and make a direct measurement. Right now, my multimeter is set in ohms, and it's going to measure. So what I'm going to do is I'm going to measure the resistance across all these resistors. So here is for R1 is going to be 97 ohms. R2 is going to be 151. R3 is going to be 329, and R4 is going to be again 97 ohms, and R5 is going to be 336. So these are the measurements that we make. So I'm done with the resistance measurements. What I could do is I can connect the power sources. So I make before I do that, I measure the voltage source that I'm going to use for 12 volts. So here is, I'm going to set my multimeter to voltage measurements. And I set it to 20 volts because I have 5 volts source, and I connect my power sources to the voltmeter. So here is the negative side is going to get connected, and also the positive side. So here is, I'm making these two connections as indicated, and let's see, it should measure 12 volts if it's connected. So we lost the connection, so we get the connector reconnected. So the negative side, the positive side, connected both, and we are measuring 1 volt, which doesn't make any sense. Let's see. Okay, so it was again connection with the multimeter, so 11.98. It's good enough that we're going to accept that. And now we're going to go to measure connected. So R1, so the positive side of E1 gets connected to R1, which is this side. And the negative side is going to get connected to the R4. Okay, this side is connected. Now what I'm going to do is I'm going to connect the 5 volts. First I measure the 5 volts. So here is my 5 volts. Again, the positive side and the negative side, I'm going to connect the positive side of the voltmeter and the negative side of the voltmeter, and it reads about 5.07. Again, good enough for the lab today. I'm going to connect the positive side of the 5-volt battery to R2. So this is going to be positive side, and this is going to be the negative side. So the only thing that I can do now is I can go measure the voltages across each resistor. So here is for V1, it measures at 2.47. V2, again, I'm connecting the positive side of a voltmeter to the positive side. So here is V2 is going to measure negative 0.58. Okay, and also for V3, I'm going to measure positive side goes here, the negative side goes here. V3 is going to be 7.01. V4 is going to be 2.47, and V5 is going to be, again, I'm connecting negative to the negative side and the positive, so negative 1.31. So these are the voltage measurements across each resistor that we made. Now if we want to make current measurements, what we're going to do is we're going to, again, change our multimeter to 200 milliamps and make a measurement of the current. So the very first thing that you have to do is whatever current that you have to measure is you have to disconnect the part of the circuit. So here is we want to measure the R1. So what I'm going to do is I'm going to connect the power source from R1, connect it to the positive side of my multimeter, and go on the other side and make sure that multimeter is connected the right way. So here is, I'm gonna connect it like that, and I'm gonna connect it to the R1. So for R1, the current going through R1 is going to be 2.5 milliamps. I'm sorry, 25.1 milliamps. So again, you reconnect it and you do the same thing for R2. Again, for R2, you connect the positive side of this to this, and the negative side is going to get connected to this. So it measures negative 3.7. So R3 is a little bit more difficult. Let's just do it the last. So I'm going to measure R4. So R4, again, this is going to get connected to the negative, and this is going to get connected to positive. So for R4 is going to be 25.1 again. For R4, the current going through R4. And for R5 is going to be negative 3.7 milliamps. So the last one is going to be R3. So what I need to do is disconnect one end of this resistor. So I'm just going to disconnect it from this end. Okay. And connect my negative side to this side and my positive side to the other side. So it's a little bit difficult to make a measurements like this. And it reads 21.1. So these are all the measurements for, so this is the current going through R3.